Talking Industry, topical debate from the worlds of automation, manufacturing and engineering. Brought to you by DFA Manufacturing Media.
So good afternoon everybody. Welcome to this Industry Live event which I've entitled Fluid Power and Factory of the Future. Let me first of all up front introduce my two fellow speakers who are going to help me this afternoon. First of all, Martin Kostin of SMC. Martin is a drives and network specialist. He's been in his current role about 5 years, really at the sharp end of application, engineering and sales support. Martin also has some deep experience in network devices and solutions. And previously he's been involved in sensor applications, for example for automotive and also vibration analysis. So thank you Martin for supporting the event. And I've got another Martin, which is a little bit confusing, Martin Hoskins from Bosch Rexroth. Welcome Martin. Martin is the UK Sales and Customer Development Manager for Bosch Rexroth. He's been with Bosch Rexroth for over 25 years. He has a lot of experience in sales and also project business. So welcome Martin, and again, thank you for supporting this event. So let me first of all kick off this session with just an explanation of what I mean by factory of the future. Here we see a slide that shows an image of what I have a vision in my mind, factory of the future. Basically we have four walls, we have a ceiling, we have a floor, but everything else is flexible. All the production machinery, the assembly machinery are smart, they're connected, they're flexible, and of course they are fully automated. And don't forget, in this factory of the future, we have the next generation of production and maintenance managers and engineers. These guys have been brought up in our digital world. They are used to getting what they need in life with the click of a button. So, for example, if I imagine my kids running the production plants of the future, God help us, because they're used to using their iPads, getting what they want at the click of a button. So using their smart devices. So this is my vision of factory of the future. And against this digital backdrop, fluid power will continue to move industry. And this is one of the key messages that I have. Fluid power is important and it will continue to drive industry. We will continue to be as important tomorrow as we are now. We supply the control, the motion to ensure that production in the UK keeps moving, keeps turning. And in fact, about 60% of our industry, 60% of production in the UK actually in part depends on fluid power solutions and products. Products and solutions that are being displayed in these two halls today. Our industry actually represents about £1 billion in the total market in the UK and Ireland. So today we are very important. And the way that our industry adapts going forward is of course extremely important to fluid power, but also to UK industry. And it's the future that I want to focus, obviously, a little bit on today. In our industry, when I talk about fluid power, our industry is very diverse. And here you see a slide of, really depicts all the people that are in this room. In the main, you see the diversity of the fluid power industry. So on the left-hand side, we have manufacturers and suppliers who focus more on the mobile machinery, the construction market. They supply valves, they supply transmissions. Going across, you can see industrial, hydraulics, valves, controls, transmissions, very important. On the right-hand side, we have manufacturers and suppliers who focus on actuators, whether it be hydraulic or electro-hydraulic or pneumatic or electro-pneumatic. And of course we have industrial pneumatics, where we have a lot of automation combined and mechatronics. And very importantly, we have people, again in these two halls, that manufacture fittings and hoses, which are the means to transmit the power backwards and forwards within the fluid power systems. And of course, very importantly, filtration. So when I talk about the fluid power industry, I'm really talking about the diversity of all the people that are in these two halls. But we have one thing in common, and that is fluid power. So one thing that connects us together is fluid power. So we're one family with fluid power at our heart, but we have a lot of diversity. And this is a very important industry. It's a key message from my side as a CEO of the BFPA. Of course, we have a very important fluid power industry, and for the future we must adapt, of course, but in the future will also be extremely important to keep UK industry moving. And another key message is today we have devices, we have controls that are smart, they are intelligent, and can deliver, for example, data in real time to the plant. Data that can help the factory of the future, for example, in terms of production cycles, in terms of production efficiencies, remote plant monitoring, and preventive maintenance, just a few examples. So today we can supply smart, intelligent, connected solutions and devices from our industry in terms of fluid power. We also have control systems that are open in their dialogue, protocols, for example, so that, as I mentioned earlier, from an iPad or a computer, you can change the production cycles of a machine. So the future will not really be like it was in the past, where if you want to change a production cycle, change the parameters, have a new product going through your production, you had to reprogram a PLC. It will take days, very expensive reprogramming. But no, we can change the system parameters from the iPad using open protocol. So we have a lot of solutions for the factory of the future, a lot of solutions that fit into, let's call it, Industry 4.0. And we're going to hear in a moment some brief examples from the two Martins of what we're doing today, some of the products and solutions that can be networked that will enable the benefits of data to the plants. And again, we want to deliver our message, which is fluid power is adapting to Industry 4.0. But we have some questions, and we were hoping we could debate them with the audience. Are we moving fast enough in the UK, for example? Are we adopting this Industry 4.0 technology quickly enough? And there are other questions. When compared to our competition, so when we compare the UK to China, to America, to the US, for example, are we behind or ahead in terms of adapting the automation that we need in our plants for the future to remain competitive? Are we really adopting this technology of Industry 4.0 fast enough? Another question might be, are we embracing the benefits that come from the use of the data that we can provide, such as remote monitoring, cycle analysis, preventive maintenance? Often our members, our companies that we supply as an industry are supplying to the machinery manufacturers rather than the end users. But the benefits that we talk about today are really in the production area, in the end users. So a key question is, are we embracing this? And the benefits, of course, because they are really in the end user, we need to talk more about the cost of ownership, the long-term cost of ownership, rather than the upfront cost of a capital investment, for example. And so a debating point might be, as end users and OEMs, are we really willing to consider this cost of ownership as the main criteria for specifying a new system? Or are we really wrapped up in the upfront budget cost of the initial capital investment? And maybe we'll hear a little bit from our experts here, because they're at the front end, they're selling this technology to customers, and they're coming across these issues and topics, I'm sure, and we can debate that later. So before we get into the debate and the questions, I'm going to ask the two Martins to present a kind of brief picture to you, just to set the scene of what the fluid power industry is doing today, what we can do today. So it's just fairly brief examples of what is possible and what we're doing, offering solutions to supply into this factory of the future, Industry 4.0 environment. So I'll invite, first of all, Martin Kostin from SMC, who will talk. His specialist subject will be pneumatics, smart and intelligent pneumatics, and then Martin Hoskins will come on the stage and talk about modern and intelligent hydraulics. So thank you, guys. I'll hand over to Martin Kostin from SMC to begin with. Thank you, Martin.
Okay, hello everyone. Hope you're having a great show so far. First of all, I'd like to thank Paul for inviting us along today and giving us the opportunity to go through some of the different types of valve manifold system that SMC has to offer. But perhaps more importantly is to go through the benefits that they could bring to you and your businesses as our customers from a smart factory point of view. So we're going to start off by looking at some of the different types of valve manifold systems that we've got and some of their features and benefits, which will mean a lot more when we start to look at the benefits that they can offer you and your businesses. We're well aware that these differences can be different from OEM and an end user perspective, so we'll cover some of those differences. And at the end I've got a slide which shows you what our customers are asking us for from this level of equipment and how we are responding to that and what values and benefits that will bring for smart factories of the future. So I think it's fair to say that there's always going to be a place for pneumatics in machine production. There's a lot of movement towards electrics, but for reliability and proven robustness, I think pneumatics will always have a place in industry. And yes, there are a lot of technical advancements being made in pneumatic componentry. There's always a new, smaller, lighter valve. There's always a new energy-efficient vacuum eject system. But we're not here today to really talk about those developments or how those individual components are being improved on, but more to the point of how these pneumatic components are being integrated into field bus networks and then what advantages that's going to bring us for our Industry 4 or smart factories in the future. So let's have a look at the different types of valve manifold system that we've got. Hopefully, technology one there, hopefully reasonably familiar to everybody as a way of moving away from individually wiring every single valve back to a system is the traditional D-sub connector. So yes, you have got the advantages of only running a multi-core cable, but you still have up to 25 cores that need to be stripped and ferruled and terminated. And if you put in that through JBs or fuse terminals, for example, that number can easily triple. And what that gives us is a labour-intensive way of wiring things back. It takes time to do it, and also it's fraught with the possibility of people making mistakes, which again can add to further commissioning time of the machine. And because of the number of cores available in a standard D-sub connection, it's also limiting us to 24 solenoids. And in the smart machines that people are looking to build today, quite often that's not going to be enough on a single network. So we're also finding that end users are now demanding from OEMs that machine build times are quicker and more flexible. And we're seeing OEMs that just are not capable of producing machines as fast as the end users are requiring. So with the systems that we're looking to supply, we're looking at what can we do about that. So technology number 2 that I've got there at the bottom is our EX260 series. And really that's just the first step of getting your valves onto a network. the D-sub connector is just quite simply replaced with a network adaptable IP addressable unit. As you can see there, we've got all the different networks available for this, so it doesn't really matter what PLC or what network protocol that you're looking to use. All we need to do is swap the header or the head unit to match that. Also, because we're doing it on a network, we're not restricted so much by the number of cores, so we can give you up to 32 solenoids now instead of 24, which is a lot more helpful, and hopefully you can see that's a good increase for smarter machine building. But why just stop at valves? Technology 3 here, the EX600 range, shows us how on the same IP address or the same network node, we can also be connecting back a large number of input devices, outputs, analogs. We can put IO-Link masters on there for transmitting IO-Link sensor information back as well, all on one IP address and all on one node on the network. A couple of advantages of that is it provides you with a much simpler topology for your machines, which is of advantages to both OEM and end users, which we'll look at in the next slide. We also have built-in web server technology for that, and some of you may know what that is and some of you won't, and I apologise if I'm using terminology, but the web server enables a lot of simple checks to be done for things like checking input statuses. You can actually drive outputs from it, you can see analog values coming back from it, and this is all done with a simple connection with a laptop, so you don't need to be a PLC or a controls engineer to be able to get some really useful data back from these types of systems, and that could save both OEMs and end users a lot of time and a lot of money. You can see from the picture that we've also got M12 and M8 connections there, and another advantage of that would be that obviously you've got a lot less wiring to do, but also it might mean that you don't have to put these things in a box or an enclosure anymore, because all of a sudden you've got an IP67 solution, and that might be enough to save you the need for an enclosure, more glanding, more wiring, more build time. So the advantages are really starting to stack up, I think. Looking at the technology number 4 for us is another way of further removing the cabling is to look at doing this from a wireless remote I/O point of view. And the real point of developing this system was to be able to remove the comms cable from the situation where it was either likely to be damaged or it's difficult to route in the first place. So that was the idea of why we brought that out. And on a product point of view, I'm afraid, the 3 things I get asked about the wireless system really is, the minute you mention wireless, people want to know, well, how reliable is it, how fast is it, and also how far can I transmit from masters to slaves or base units to remote units. So the bottom line is, from a reliability point of view, is it's extremely reliable. We try to ignore the word wireless, really. It's more of a description than the technology that's being used. It's a radio-based system operating in the 2.4 gigahertz frequency, which is well outside normal factory noise. And we're also frequency hopping as well. So the communication between base and remote units is frequency hopping every 5 milliseconds. So it's more or less impossible for the frequency to get damaged or interfered with. The bottom line is, it was developed initially for use on welding robots, and any of you familiar with that type of technology will know that it's one of the worst things for electrical noise, and this thing's worked perfectly on those. From a speed point of view, the base units will connect to the remote units in 250 milliseconds, which by standard terms is extremely fast. A typical network connection can take anything from 4 to 10 seconds time. So if you've got tool changer applications, for example, and you have a room full of robots all doing lots of tool changes, you can soon start clawing back minutes, hours, or even days of lost production just from simple tool change actions. And from a range or a distance point of view, we're looking at 10-meter range, which doesn't sound a lot when you say it, but if you start to think of it in terms of a robot cell or a typical general machine automation cell, it's actually a reasonable distance, particularly if you were to do it in a radius form rather than a direct line of sight form. So we're also trying to get OEMs and end users to think about how they utilise their floor space and how they design and build their cells. It doesn't always have to be the way that they've done it in the past. So both of these systems will give you up to 32 solenoids as the EX260, but will also give you up to 128 I/O as well to utilise and use. So there's lots of different benefits really for OEMs and end users, and I'm just going to throw a couple out there really which might spark a few questions or whatever for us later on. From an OEM point of view, we can basically look to help reduce the build time, reduce the installation time and reduce the commissioning time. The bottom line is if you've got less wiring to do, there's a lot less problems to do with installation and a lot less troubleshooting to do from a commissioning point of view. Also, from an OEM point of view, if you've got no wiring, you've got no wiring diagrams to do, you've got your bills of materials all of a sudden become a lot more streamlined and simplified. And again, all these things need to be considered as money-saving and time-saving opportunities. We've also got the possibility of once you've got this kind of equipment onto a network, you've also got that possibility of doing remote access. And I think we've probably all heard from people selling remote access equipment of the benefits that brings to both OEMs and end users from a time-saving point of view, especially with the point of view of reducing the downtime, which is initially beneficial to the end user, but if an OEM can get someone's machine running quicker, that's a benefit to them as well. So the bottom line is that all of these advantages are there to lower costs and improve our production efficiencies. A couple of things from the end user. By using the web server functionality that I mentioned earlier on, that makes fault finding a lot easier, and it means that you don't necessarily need to start calling in PLC experts or controls engineers to find out some reasonably simple things that are going on in the system. You can easily train a maintenance technician with a laptop to do those kind of jobs, which is going to free up time for the controls guys to be doing something more useful. So hopefully there's a couple of useful things there, and again, any questions or queries on that, feel free to shout out later on. I said at the start that we'd have a look at what the future is looking like, and this is it's a bit of a busy slide, I'm afraid, but when you start trying to understand the message I'm trying to get across, it was as simple as I could make it, I'm afraid. We realised that our remote I/O systems, or anyone's remote I/O systems, from a machine and a factory point of view, sit pretty low down the food chain, really. But we are starting now to realise that customers want more from a remote I/O system than just the fieldbus data to control the machine. They're also looking for the data to be available in the right kind of formats and languages for data servers to be able to handle this information, with a view to either interfacing with manufacturing systems or purchasing systems, ERP systems, and also having the data available in the right format to be able to do trending and diagnostic performance as well. The way we're proposing to do that is to have the fieldbus protocols and the data collection protocols. In this case it's OPC-UA, but there are others available, and I've tried to indicate that with the blue and the pink lines coming from the remote I/O units there. If that's of interest to you, we have got a working version of that on our stand, and if those kind of hierarchical levels are interesting, come and have a chat to us and see what we're doing in the future, really. So thanks for listening, and I hope that's been reasonably interesting. As Paul said, I'll now hand over to Martin Hoskins, who's going to tell us about modern intelligent hydraulics. Thank you very much. Cheers, Martin.
Afternoon, everyone. Thanks, Martin. Really interesting. Connected hydraulics for factories of the future. It's a very brief pond skim over the topic. There's 3 points to the agenda: data and digitalization, landscape structure, and hardware connectivity. When you're thinking about connected hydraulics and factory of the future. Words such as permanent, fixed, even jobs for life. They're old words. They're not words for the new approach to business, the new approach to our sector. We've got to start looking at flexibility, modular, quiet, efficient, all the words which benefit the environment, benefit the industries, but where we've got to go. We've got to learn and develop to be in that future-orientated industry. Through the years, we've worked very closely with various companies in production and have learned that IoT has a very, very forward-thinking benefit to both the designers, the systems providers, but the end users and OEMs. By working together, we can all then develop this, the digitalization fight for the future. We need to grasp and develop this digitalization age. This is quite another busy slide, but the premise of the slide is we've always had data available. The power units we've installed in the 60s, 70s, were all able to give us information. We were always capturing data, whether it's through temperature, levels, pressures, linear movement, but we never had any way of utilizing that data, capturing the data and making it work for us. Modern technology has now assisted us in doing that. We're in a position where we can gather that data, which has always been there but never been used efficiently. We're gathering that. Through the technology now, we're able to store it securely in virtual environments, and there are systems available now that, using algorithms and various platforms, we're able to interpret that data and create solutions and questions for the end users, whether it's plant, whether it's the manufacturers. It's data. We're in a data-orientated situation at the moment. This is a typical topology of a modern hydraulic manufacturing type layout. You can see, and some people may never have seen it before, a new type of hydraulic power unit. Gone are the days of oily, noisy, dirty hydraulics hidden away, running 24 hours a day, 7 days a week. These are virtually plug-and-play systems which people are developing. Plus, they look sexy. You think of an iPhone is a sexy piece of equipment, same as an iPad. Why not make hydraulics in the same manner? So here you can see a totally integrated system, hydraulic power unit, with all the sensors and instrumentation within it via the I/O switch pad, collecting the data back to the central processor. This also includes data from the motor pump set, whether it's the encoder, pressure, temperature, speeds. You can also incorporate existing systems, press systems, bending systems, machine tools. You gather that data through the central processing system, plus the engineer on site is making his configurations, he's altering his timings, his approaches. Via then again another switching network, the options are available for 4G networks, 5G networks, or even internal environment networks to store that data on clouds. That data, using the right platforms, can then systematically give you real-time data which can be used then on mobile devices, as has been mentioned by both Paul and Martin. You've got your iPads, you've got your mobile phones, you've got your desktops. However you want it, that's now available. And this isn't science fiction. This is today. It's going to develop further, and we need to work together to be able to pull this together. Going into some of the hardware, as I mentioned, this is what we class as the Citro box, part of the Citro family, a new development and a new way of thinking of providing hydraulic power units for industry. We've got to make them modular. You've got to make them as plug and play as possible. Fully integrated, whatever platform you are using within your plant, your bus systems, via the Citro box, help you make it mobile, modular, and bankable. You can bank them up to create larger powers. Typically, a normal factory would have existing press systems, machine tools, you have small power units, you have various actuators working, whether it's linear or rotary. Anything with feedback can be captured and then utilized via an IoT gateway. Then you have a plethora then of various platforms to run the diagnostic systems for your plant and your systems. We have a system called Odin, which is a predictive analysis tool, which from day one will data log and blueprint what your system is. And then in the background, it tells you the progressive deterioration of various aspects of your plant. And from that, you can make informed decisions as to how you manage it, what your next actions are, and virtually telling you when that system is going to break down next. So it helps you align all your costs, your preemptive purchasing of spares, and manning to be able to carry out these rectifications. As I said, only a whistle-stop tour. Existing data, the data exists. We have data, all our plants have data. It's capturing it and utilizing it and making it work for us is the key. We know the landscape. We already have a landscape, but we can make it better. We have to be brave. Systems are out there to be used. New developments are out there. We haven't got to do it in a particular manner because they did it that way 20 years ago. Let's think ahead. Let's be proactive rather than reactive. Make things modular, make them agile. Plug and play, utilization of floor space is key, so let's make things work for us rather than us working for it. It's time for everyone to learn about these opportunities, these systems, the equipment that's available. We need to be brave and we need to move and move now to make it work for Britain. So on that note, I know it's only pond skating and looking at the top level, but I'll hand over to Paul now and hopefully to yourselves. Hopefully we've dropped a few seeds into the pond for you to consider, and we're waiting.
Thank you. Thank you. Thank you, Martin. Thank you very much. So, thank you guys. Again, that was a little bit of a whistle-top tour with a key message that we have technology available today to deliver these benefits in terms of data, to enable plants to use the data to be more efficient for the future, yeah? And we're interested to have a dialogue and some questions. Maybe I can just start it off, if you don't mind, because a couple of points I mentioned earlier, and these guys are actually at the sharp end. They're selling this technology to their customers, yeah? And one thing that I'd like to know, and I maybe ask you, Martin Kostin, to start with, what sort of reaction do you get? Because again, we're selling the benefits. They're great benefits, I think you agree. Benefits of supplying data, wireless systems, network systems that deliver a lot of benefits to our production plants, that has the benefit of not only remote monitoring, but also of using that data to be more efficient, yeah? But these benefits, as I said earlier, are really more in the end user area. So I wanted to ask you, what reaction do you get when you're selling this technology to your customers? Yeah, what kind of barriers do you have what kind of discussions do you have, and can you sell this cost of ownership? So perhaps you can just comment on that, Martin. Yeah.
I can certainly try. Is this on? Yeah. Okay. I'll certainly try. Yeah, we do have a lot of discussions about that, and obviously we're out there making people aware of the technology that's available for them to use. And as I said earlier on, the arguments or discussions they have with OEMs are very different to those for end users. But I'm not sure that all the benefits are there for the end users, as Paul said, because in our experience there are a lot of things that OEMs can be utilising this technology for to make building their systems quicker, easier, more flexible. And I think end users are also looking to OEMs to give them ideas about how their facilities can become more flexible and more adaptable. We're finding end users now don't want OEMs to build one machine that runs one particular product. They need flexible machines that can run multiple different types of product down. And the technology to do that is all there. I think as Martin said at the end of his presentation, we have all the technology available for this. There's still some resistance and reticence to actually investing in it. And so I think, hopefully to sum up that and answer your question a little bit more directly, Paul, is one of the biggest kind of discussions that we have is people will quite openly discuss the technology. They'll see realise the advantages of it, but you still end up coming back down to, well, how much more does that cost than the way that we've always done it? And there's this almost like reluctance to look into total ownership costs and just keep focusing on the initial cost of the hardware investment, which 9 times out of 10, you're talking less than hundreds of pounds of difference. You're not talking tens of thousands of pounds worth of investment in addition to how it used to be done. And this is kind of the biggest issue that I certainly seem to come across is the lack of will to invest in this type of technology, even when the benefits of what it's going to provide are quite clear and they're understood. So that's hopefully that answers that question a little.
Yeah.
But
thanks, Martin. Yeah. So maybe another question I have just for the guys to get them speaking as well a little bit is, you know, Martin Hoskins, you talked about the future of hydraulics. You mentioned, you know, we are actually producing sexy components and solutions, which is a nice way of putting it. We are orientating ourselves for the future. And I mean, you've had 25 years with Bosch Rexroth. You've been selling projects for most of that time. Yep. And now you are selling solutions which are connected. You have to not only talk about the hydraulics, you have to talk about the connectivity, you have to talk about the electronics, you have to talk about the controls. How are you finding that? And in your team, I know you've got a team of about 10 people, how do you attract the right skills? I mean, have you got an issue with getting the right kind of people into your team and into the industry to actually be able to sell this technology effectively?
Yeah, that's a very good question. The skills pool is quite shallow at the moment. We can usually get someone who has maybe experience in one particular sector, not necessarily a product. Getting an overall person who can take on multiple aspects of projects, people like that are like gold dust. They're the future we need to be trying to develop. And unfortunately, you look at the demographic walking around today, there's a lot of good engineers which we do recognize.
Like me, you mean?
Which we do recognize because it's quite an incestuous sort of industry and engineering that everyone's involved with. And we need to A, maintain that, but B, develop the new guys who can integrate one technology to another, because the people who can do that are the people with the magic wand, and they're the future. It's okay looking at one particular technology and keeping them separate, but they're no longer separate. We need to look at it as a whole, as a solution. We don't have guys on site who just look at electrical or hydraulic or pneumatic. We need multi-skilled but very good multi-skilled people, and it needs to be coming through education.
Very interesting. Thanks, guys. So maybe just open to any questions from the audience. I think my key message, you know, I would say not old but experienced guy from the industry. I've been with the industry for 37 years. I was formerly in the US. I was the CEO of Bosch Rexroth in the US. And before that, I was responsible for worldwide sales based in Germany for Bosch Rexroth. And I've traveled the world, and I've seen all sorts of industry. I did a lot of business in China. And of course, I see, working in the US, working in China, etc., I see the automation that's happening. Yeah. And this is a key to competitiveness in our industry. This is really key. So the things we're talking about, not de-skilling, not actual de-skilling, because we still need, the companies that automate don't actually have less people, but they are more efficient, and they can make more money, and they can invest in themselves. And I see this all around the world. You know, China is today the biggest importer even of robotics, yeah? And that tells you something. You know, China used to be low cost, low labor cost, but today it's really automating to be competitive. And I see the same topic in America as well. So a key question is, you know, the UK industry, I've only recently come back, so I've not got a great impression. But the feeling I have is, to be competitive, we have to really move forward with this kind of technology. Industry 4.0, connected industry, whatever you call it, is one of the keys, yeah? So I think these guys got over the message. The technology is available. The benefits tend to be in cost of ownership. And some of the barriers are still there. And also the skills, you know. I'm the CEO of the BFPA at the moment, and it's the key topic of all of our members is, how do we get the right people, yeah? And have we got the right framework, even in the higher education? Have we got the right courses that really churn out these kind of engineers who are not in a pigeonhole anymore? They're not necessarily just mechanical, just electrical, like I'm a mechanical engineer. They are more rounded people that can talk this language and that can connect and network in the terms of mechatronics and automation. And this is a real challenge for us. So we need the skills, we need the products, we need the solutions. Many of the products are already here. We have the benefits, and we can generate the data. The data is sometimes difficult to interpret, so you mentioned algorithms, and to really make the data meaningful is also a kind of a product in terms of software that we have to deliver to our customers, how to interpret the data, yeah? So I've done quite a little bit of talking, but I wanted to get the message across. I've been 37 years in the industry, and I think it's a really exciting time. And when you wander around these halls, you can see this technology, you can see our industry adapting for the future. So it is exciting. And what we want to do, part of my job, is to bring younger people into the industry, and really get them motivated, because it's a very important industry now, and it's a very important industry for tomorrow. So anybody got any questions for either me or for the two Martins? I'll just start at the back there. Do we need a microphone, or do I? You can shout at me.
Thank you. Hi.
Hi.
Do you think the supply chain issues with the semiconductor business is going to slow us down with Industry 4.0? Just a thought.
Yes. It will, in certain circumstances, slow us down. I think we've learned to manage issues over the last, I don't say 5 years. We've had various issues, whether it's Brexit. We're in a better position to manage these things now, but it will affect us. But one of the things I think is supply and demand at the moment, not just semiconductors, it's materials, it's raw materials, it's the steels, it's that sort of area where I think we're going to struggle. People will want to invest because we see it quite buoyant out there with capital investment, but it's maintaining the supply chain to fulfill that investment, I think, is going to be the real challenge for the UK. Personally, I don't know whether Martin has.
Yeah, I agree with everything that you've just said. Just to sort of narrow the question down, did you mean like this the supply of chips and things for intelligent solutions? Yeah, I mean, we saw that probably a couple of years ago. We saw a dip in the availability of chips a couple of years ago, but that's not kind of what's holding our company back from a supply issue at the moment. The technology side we're not seeing an issue with. We're, like as you alluded to, we're seeing an issue getting raw materials, the right plastics and things to make enough components. So as far as I'm aware, we're not seeing a chip or a semiconductor issue with supplying smart products. It's the raw materials for the dumb products that we're struggling to get enough of from a quantity point of view. So I hope that helps. So.
Interesting. My question was going to be about, you've shown that the technologies are available, but you've also said that people aren't taking them up. So how do you get them started? I mean, do you start with an overall vision to work into, or do you start small and scale up, or do you try to do both at once?
From my perspective is we need to build confidence and use platforms such as this to help educate people who make decisions. As I mentioned, because we've done it a particular way for so long, why should we change? You know, that's a question from people who I talk to. But you also get questions, you know, if you talk to an OEM and say, this is the way you should go, it's sexy, it's modular, then they're saying the customer's not requesting that. They just want a solution. You go to the customer and say, look, this is what we can offer, this is what you should have. Ooh, how much is that going to cost? The OEM isn't mentioning it. So our job is to spread the word, to join the dots. Once people can see the value in what is being offered and is available, something that will run on demand rather than something that will run continuously for 24 hours a day, 7 days a week, environmentally, energy, everything around that is logical to go to the modern technologies. And you know, that's from my perspective.
Yep, from my point of view, again, I would agree with everything you've said, but maybe just to add to it a little bit, or maybe put it across in a different way, what we see is, as you quite rightly say, even if you find an OEM that's willing to use the new technology, the end user will sometimes block that, A, because of cost, or B, because they're frightened of taking on the new technology and they know they haven't got the skill sets to maintain it once it gets onto site. And again, you can't help but put the blame at their door for not utilising the right labour in the first place, for not paying for the right skill sets to be brought into their company. And again, this comes back to something that Paul was saying earlier about how do we change that? We are where we're at now. End users struggle to find the right skill sets to be able to run the machines that the OEMs want to build. So it's not a case of that they won't do it. There's a lot of objections and blockers there, even if they are convinced to do it in the first place. And it really does come back to having that engineering skill set in the industry to make it all maintainable. That's kind of what I see. And also there's a lack of discussion between the end users and OEMs as well. I still think that due to time pressures or constraints or people's lack of communication or willing to talk about these things, is that I'm not privy to the meetings that go on between OEMs and end users, but I can't help but feel that they're probably not as open a discussion as they could be. I think there's probably a lot of, no, we're not doing it like that, and that's it, without enough dialogue and discussion about what the actual benefits are. And I'm not sure that the OEMs, in some cases, are aware of how they should be selling their machines to the end users by explaining those benefits properly to them. So again, there's probably a skill set shortage in how that happens.
Yeah, I think it's a really good question, and from my experience as well, I think we're in an evolution rather than a revolution. So when I've been experienced or exposed to this kind of technology and this kind of selling, normally in the room is some guys, some people who understand the benefits or the new business model that can be generated from having the data. Yeah, and that means you have to have the people with a different mindset in your organization that think about how can we make money in a different way? How can we add some value against our competition by using data in the right way? And if they get really into that and they can map out a strategy which involves a new business model or a new way of doing, using data, using the benefits of data, then I think it happens. It happens, and they can see that they can make money out of it, they can see that they can make efficiencies out of it, and then it will move forward. So we will definitely move forward in this direction, but I think it will be an evolution rather than revolution. And as the younger people, let's say, come into managing production facilities, as I've said, we will definitely have a different mindset managing the plants, I think, going forward in the future, which will really, I think, embrace a lot of the technology that we've been talking about today. Is there any more questions or comments or feedback?
You mentioned universities and skills. In your experience, to everyone, do you feel that universities are actually teaching the right skills for the industry? And if not, is going to university actually the right path, or maybe the industry itself needs to enhance apprenticeships?
Yeah, I'll start and then you can comment, guys. So I think it's a very good question. I've just been talking on our stand to a department, a government department, who's looking at how to bring together apprenticeships and skills gap topics for manufacturing. Yeah, and I think it's really important in the UK. You know, I mentioned when I was in China, they have a manufacturing strategy, which goes from the start to the finish, skills, local for local, everything. They have a manufacturing strategy from now to 2030. And I think if we answer your question about skills, this is, as I said, the top number one issue that we have, I feel, that really needs to be looked at and addressed. And it's across the whole spectrum. It's not just universities, it's apprenticeships, how we attract younger people in engineering to begin with. How do we really make it exciting to younger people to come into the industry? And to talk about universities, I do feel as though we should be teaching and having courses that really embrace the spectrum of what we've been talking about today. So if we talk to the companies in here, they will tell you we don't need a mechanical engineer necessarily, we don't need an electrical engineer, we don't particularly need an electronics engineer. We need somebody who can look at this total system and help us to be able to either sell it, engineer it, or support it. Yeah? So you need to have multidisciplines, and what's happening is companies are taking on people from university, finding that they're not quite the finished article, and spending 2 or 3 years to get them into a position where, like these guys, they can talk competently about a complete system. Because the customer doesn't want to talk to 2 or 3 people. The customer might even have 2 or 3 departments, yeah? But they want one integrated system. So it's a very good question, and I said it earlier, I think if we can influence higher education, if our members could influence higher education, that would be their voice, right? Good question.
Can I'm a great advocate for apprenticeships, but of the true apprenticeships, whether it's a 4-year or 5-year apprenticeship, then the progression to university. That, to me, that person is gold dust. If we could find 1 out of 20 people who've followed that path, I think they're of such a significant level, as opposed to someone who may have maybe done his honours, his bachelor's, whatever. It's that practical side that we need to develop of the education. It's not the be-all and end-all, because we have to have all tools for all jobs, for all aspects. But I do agree with Paul, we need to have a strategy to get true engineering back into the curriculum of schools. And for people to come along and say, I'm apprentice trained, so how long did you train? Oh, I did 12 months. Doing what? Oh, I did a bit of this, but that's not apprentice trained, in my opinion. Maybe I'm old hat, but apprenticeships should be proper apprenticeships with education on top.
So I think it's just over to me to say thank you for attending today. I hope you found it interesting. Thank you so much to the two Martins for adding your ingredients of expertise, and you're doing the business at the front end, so I think your voice was important today. And I think hopefully our messages have come across loud and clear. We have an exciting fluid power industry with also an exciting future. So thank you very much, everybody.